Okay, so truthfully, I had to pause because I had to figure out how to actually scale the graph. Notice that my x and y axes are scaled the same. It's a little bit funky in the sense that each interval is 25, but in keeping the x and y axis consistent, I can actually use the slope as it's written. Okay, so take a look at the equations again. We've got pink, green, and then blue and purple. And the blue and purple are the actual common sense constraints. So those are what I'm going to graph first. All right, graph with me as we go. Blue says that x is greater than or equal to 0. If x equals something, that's our vertical line. So that's going to cut through the x-axis. It's a little tough seeing as how I'm on that axis. So I'm going to draw it a little to the side. It is a straight line. Whoa, that's not straight, but you're used to that with me. And I'm going to shade it because I'm greater than or equal to. Okay, then our purple line is the y is greater than or equal to, which means I cut through my y-axis, which means that I am horizontal. Okay, again, I'm going to be a little bit above so that you can see where I'm drawing, and then I shade above because I'm greater than or equal to. The equal to just means I have a solid line. All right, here's where it gets a little crazy. So for the pink constraint, my y-intercept is going to be at 600. So I'm going to put a point at 600. Because my axes are the same, the intervals are broken up the same, I can use the same slope. So I'm going to go down 1, 2, 3 units and over 2. 1, 2, 3 and over 2. 1, 2, 3 and over 2 and so forth. So go ahead and finish on your notes with me. 1, 2, 3 and over 2. Ay, ay, ay. And that's my kitty if you just heard her purr. One of them. 1, 2, 3 and over 2. 2, 3 and over 2. 1, 2, 3 and over 2. Oh, that worked out nicely. Okay, so then go ahead and connect them. Now it says that y is less than or equal to, so that means I'm going to shade below the line. But if you don't know, pick a point. Pick a point that is on one side of the line. So looking at my line, I could pick 0, 0. If I plug in 0, 0, I'm going to end up with 0 being less than or equal to 600. Is that a true statement? Hopefully you say yes. So that means that I'm going to shade in this region. Okay, you can always pick a point to test just in case you don't know. Okay, the last one is green. Yay, so exciting. All right, green, I have a y-intercept at 400, and my slope is negative 1 over 2. So I'm going to go down 1 and over 2, 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 and so forth. Okay, so my line's going to go this way. It's going to be solid. And again, I'm a less than. So I'm going to shade this way. Now we talked about yesterday with a system of linear inequalities, the shaded regions represent where all the solutions lie. But if it's a system, you're looking for where all of them intersect. That is what is super crucial to these types of problems. And that's what we need to find. So if you can see, all of them intersect in this region. So I'm going to go ahead and sort of shade that in to represent. Those are all the possible combinations of tables and chairs that are going to help us find profit for our chain of stores. Yay, that's what we want, right? Granted, yes, we can't have a third of a table and a half of a chair, so we have to account for that as well. But with linear programming, and that is what we're dealing with, okay? So you might as well write that down right now. It is called linear programming. Yay! And I know I'm not as exciting just with my voice. I'm not dancing around the classroom, so my apologies. We are doing what's called linear programming. Okay, this area, the area that is shaded, that is called the feasible region. Write that down. The feasible region is the shaded area where all of your solutions lie. Okay, again, it is the region where all of your solutions lie to the system of inequalities. If you are not done writing that down, pause the video, rewind it. You'll notice there are 4 intersection points for our feasible region. Those are the 4 points that are going to help us maximize or minimize our profit. I'm going to label them A, B, C, and D. Okay, so A is at 0, 0. That's our origin. B, nice because you can see it, is at 0, 400. C is at, it looks like 200, 300. And then D is right down here. It's at 400, 0. Why is this important? The intersection points along the perimeter of your feasible region help you maximize or minimize. Remember back at the beginning when we had that objective function? Haha, this is where that comes into play. So our objective function was 12x plus 18y. Guess what we're going to do with these x and y coordinates? What? Plug them in, you say? Why, yes, we are. So if we plug them in, we get 12 times 0 plus 18 times 0, which gives us a big fat profit of nothing. Okay, for this one, we get 12 times 0 plus 18 times 400, which is, I'm not going to lie, I was ill prepared and didn't have my calculator. And my husband is filming this on our phone, on my phone. Okay, so this gives us a big fat profit of 7,200. For this one, again, I'm taking these intersection points, the x and y's, and plugging them into our objective function. Okay, for this one, that means we've got 12 times 200 plus 18 times 300. Hopefully you're plugging this in with me as I do it. Okay, so that gives us a profit of 7,800. And then last but not least, we've got 12 times 400 plus 18 times 0, which I think is 4,800, but let's check. Because it's late, I'm not going to lie. Okay, so 4,800. So if we look at all three, definitely to maximize, it's going to be C. So the very last step when you are solving a linear programming problem, because you're being asked a real life question, is to answer in a complete sentence. Don't groan. I know, it's not English class. I hear that every year. I get that. I'm asking for a sentence, people. Just a sentence. So here we go. To maximize profit. Write this down with me. To maximize profit, we, because you are the managers, we must sell. Okay, remember, X were the, what? X was the number of chairs. Okay, we must sell 200 chairs and 300 tables. Okay, again, the last step was to answer in a complete sentence. So we have to go back to the beginning and actually say what our X and Y values were and what that means to our answer. Okay, so key things. Identify your variables. Write the objective function. The objective function was based off of the profit. Create your constraints. Don't forget the common sense constraints. Okay, these don't come out of thin air. All of this is based off of information that you're given. And then we had to graph where the shaded regions intersected was called your, was called your feasible region. That's where all the possible solutions lie. Granted, yes, you can't have a third of a table. We talked about that. That's important. The intersection points are possible maximization or minimization of your profit. We plug them into the objective function and voila, we found that we could be rich. Gosh, wouldn't that be amazing? All right, good luck, guys. Be good to your sub. I'll see you tomorrow.